Okay, so this is 8.3 chemistry. 8.2 isn't included in the material. All the teachers said. Let's just start. Okay, it would be useful to memorize this table in the book over here. Just know them, the names, blah blah blah. This is this. 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 This doesn't really matter. Okay. Know that mass always has the unit U. So in case you see it, don't get confused. And the book is important. You can go over it. So I'm not gonna go over the book. Also the notes. The notes over here. We go down to the part here. Yeah. These are important. They might ask us a question like this in the written. I don't know. But I'm pretty sure they're gonna ask a question that has to do with fill out the particle. I think that will come. المهم, let's do the quiz. But like these definitions are important. Fission, in which a nucleus splits. Fusion, in which it combines. And these definitions, you won't really see them. And then they might ask, what equation is the energy transferred? According to what equation? You have to say E equal mc squared. Okay, because some energy is lost in some reactions. Okay, so scientists had to prove it, so they used E equal mc squared. That could come. What's all this? Okay, I don't think this is. I don't think this is coming. المهم, let's go back to the quiz. What are true? 1 is a proton, صح? Proton has charge +1 and mass 1. E plus 1 is a positron. When is it a positron? When it has 0 mass but positive charge. This is an alpha particle? Obviously not. Alpha is the helium. This is oxygen. The mass of this is 141 U. Yes, just look at the charge. 141. Question 2. Consider the following equation. What will be true about x? Okay, the way to do it, you just add them up on each side and then subtract. Okay, here you have 235. Okay, here you have 141 plus 92 plus 3, because 3 times 1, yeah, which is going to be 233, 236. Okay, so that means obviously here it's going to be 1, صح, to complete the 236. So obviously here it's going to be 1. How about the charge? Here we have 92. Here we have 56, 36, and 0. The 0 doesn't count. 56, 36 will be 92. So obviously there's 0, right? No need to add anything. We can just keep it at 0. So our x is going to be 1, 0. Which one is 1, 0? That's a neutron. Okay, if it has no charge, it's a neutron. Okay, it has a mass equal to 1 and the charge equal to 0. It's not a positron or a proton, and its mass obviously is not equal to 0. It's all equal to 1. Question 3. Which represents, okay, it undergoes an alpha emission. Okay, alpha emission يعني alpha emission يعني it's in the product. Okay, let's see. Alpha is always He42. Okay, helium-42. So let's check the first one, for example. 242 plus 4 is 246, but here is 238, so obviously it's wrong. Here it's wrong because it's in the reactants. You can prove it. If you add them up, you get 242. Here you have 239, so obviously that's wrong. Here it's correct because you have 234 and 4, so 238, and then here you have 238, so they're equal, and then here you have 90, here you have 2, add them, you get 92, and they're equal, so that's correct. With the last one, I'll continue doing them. 237 plus 1, 238, okay, 92, 92, okay, they're both equal, but realize here they used a neutron, but they ask for an alpha emission, which is helium 42. Okay, you can't use a neutron when they're asking for alpha. وآخر واحدة 235 plus 4, 239. Oh, where did I go? 235 plus 4, 239. Why is this wrong? Because they want alpha emission. Yeah, okay. Yani that means when they say alpha emission, that means the uranium released, okay, the alpha. Okay, in this case, it's not the uranium releasing it, it's whatever this is. I don't know, like plutonium or something. But in this case, uranium is not releasing it, so that's why it's wrong. Question 4. An atom whose nucleus is U23592 has obviously 92 protons, and the electrons are always equal, and then 143 neutrons, and its mass is equal to 230. I'm not going to explain this, okay? We've had this in chem before, we've had this in physics command. I'm just going to go next. Question 5. The charge of X is 33 and its mass 86. How do you know? 235 plus 1, 236. 147 plus 1, 148. Okay, no, sorry, not 148 plus 1. 147 plus 3. It's 150, because 3 times 1. Yeah? 150. So I'm missing something over here. I need to add something plus 150 to get 236. And that's 86. So the mass of this X is 86. Okay, how about the charge? Here we have 92. Here we have 59. And there's 0 charge here for just 59. So I need to add something to this 59 to get 92. And that's 33. For the charge, it's 33. If my mass is 86, the charge is 33. There you go. Question 6. Okay, here match each reaction to its convenient heat change. Okay, there's no calculation involved here, but you just need to think about it. Okay, always remember any thing that has to do with nuclear reactions, always release the most energy. For the one with 10 to the power of 6 is going to be matched to the nuclear reaction with uranium. Okay, we're done with this one. Now, between these two, one of them is positive. Okay, they put the states on purpose. From liquid to gas, so remember, solid, liquid, gas. From liquid to gas, you're going to the right. That means you're going endothermic. And if it's endothermic, that means delta H is positive, صح? Okay, let's see. If you're going from liquid to gas, which one is delta H positive? This one, so I match to this one. This one here is just the last option left. But if you want me to explain also, when you only have a few things happening, it's the least heat change. Okay, so 30. But here you have some rearrangements happening. Okay, there's some rearrangement for the bonds. So that's why it's gonna require a bit more energy. But also the method of just checking which one's positive works. But maybe they bring two that are positive. You have to check which ones are undergoing the most rearrangements. Okay, question 7. Complete the following nuclear reaction. Okay, the way they don't give you this hydrogen. Okay, and they don't give you this. But what you have to do, look here. Here's 239. Okay, here 91 plus 146 is 237. So obviously I'm missing something to add to this 237 to get 239. Obviously that's 2. How about the charges? I have 95, and here I have 94. So I need to add something to this 94 to get 95, and obviously that's 1. Okay, so which one has 2 mass number but 1 as the charge? That's going to be hydrogen 1, 2. Okay, you can add hydrogen 1, 2, and you can add hydrogen 1, 3. I don't know why it wasn't mentioned in the book or notes, but you can do it. Okay, it's hydrogen 1, 2. If you see 2 as your mass number and 1 as your charge, you put it as hydrogen. This is actually called deuterium, because they asked that in another question. Okay, here 238 plus 4. Here is 238 plus 4 is 242. On command 242. Oh, wait, you're not supposed to see this. Here it's only 241. Okay. Down here it's 94. Down here it's 94. I need to add something to this 241 to get 242. That's 1. And then here, no need to add, so it's 0. What has 0 charge but 1 mass number? Obviously, that's a neutron. N. Question 8. Okay. Which one's fusion, which one's fission? Obviously, when they're fusing together to form one big one, that's fusion. So A is fusion. And when it's breaking down to form two, split into two different ones, that's fission. And in both of them, energy is released. You can see by energy being written after the arrow. So that means it's being released. Question 9. Okay, just match them. This is obviously proton. This is obviously neutron. This is obviously a positron, since there's no mass. And this is alpha. And this is electron. Question 10. Okay, in the above reaction, M here is the mass, right? What is it equal to? It's equal to 2. How do we find it? Here it's 239. Here's 91 plus 146, which is 100, no, no, 237. Okay, so M, obviously we need to add to 237 to get 239. It's 2. The mass of it is 2. How about what about N? N is the charge, صح? Okay, what is it equal to? It's equal to 1. Okay, therefore X is a deuterium. Why is it equal to 1? I have to write 95 here on the left. 39 plus 55 is 94. So what do I add to 94 to get 95? I need to add 1. Okay, so that means my X is 2 as the mass number and 1 as the charge. And what has 2 is the 2 is the mass number and 1 is the charge? I told you that's hydrogen, right? And that's what they call deuterium. Question 11. Okay. We did this already. I'll skip part A, but you just have to add them up. It's repeated, but part B, all you have to do is you take your periodic table and you check which one has atomic number 33. Like, let me pull up a periodic table. Okay, you will go to 33 over here, and it's arsenic. You see? So you just take arsenic. So you go back to your quiz, and you put arsenic AS, and you put the mass number of it, which is also should be in the periodic table. Okay, it should be in your periodic table. حتى no, you don't have to write the mass. The mass and charge, you already know it. You just need the symbol of the element, AS. Question 12. Okay, so again, just mass and charge. Very easy, just add 236 here. Here you get 143 plus 3, which is 146. So obviously I need to add something to 146 to get 236, and that's 90. How about the charges? Here I have 92. Here I have 54. What do I add to 54 to get 92? I think it should be 36, 38. Yeah, 38. If I add 38. For my Y is going to be 90, 38. I think that's it. Yeah, that's it. Thank you so much for watching, and good luck.